Hello students, last video lecture, which was almost 20 days back, we have seen the addition and subtraction of a complex number. In today's lecture, we will see how the complex numbers can get multiplied and then the divide. Okay, suppose we have this complex number z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. Okay, now how I showed these points on the organ diagram? By the point P and by the point Q. Okay, now what will I say? I'll use my polar and exponential form. Okay, means what? This is normal form. Okay, because we said z is equal to x plus iy. Now as I said, polar means I'll write x1 plus iy1 is equal to r1 cos theta 1 plus I sin theta 1 is equal to r1 e to the power I theta 1. So where is theta 1? Theta 1 is over here. Fine. So this OP is basically r1 e to the power I theta 1. Fine. Similarly, what is my z2? Z2 is x2 plus iy2 is equal to r2 cos theta 2 plus I sin theta 2 is equal to r2 e to the power I theta 2. What is theta 2? Theta 2 is over here. So my OQ point is basically, OQ is r2 and Q point is going to represent my second complex number z2. Correct? Now when I multiply these two, which means what? z1 into z2. So how will I multiply them? As usual, r1, r2, cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2. So I can write in short r1, r2, okay, cos theta 1, cos theta 2, cos theta 1, I sin theta 2, plus I sin theta 1, cos theta 2, and plus I square sin theta 1, sin theta 2. So all this can be written over here, and which can be in short written as r1, r2. I directly write the third step, cos of theta 1 plus theta 2 plus I sin theta 1 plus theta 2. Now this job I am going to give you to do it. R1, R2 is obviously. So first step will be cos theta 1, cos theta 2. Second step will be cos theta 1, I sin theta 2. Third step will be I sin theta 1 into cos theta 2. And fourth step should be I square sin theta 1 sin theta 2. So if you simplify that, okay, you will get a term where you will have cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 because I square. Okay, and second bracket we will have plus I times sin theta 1 cos theta 2 plus cos theta 1 sin theta 2. That's why we got sin theta 1 plus theta 2. Okay, very simple. You being mathematics student, this is not a difficult task for you to do it at all. Okay, so this can even be written as r1 r2 e to the power I theta 1 plus theta 2. Okay, now I need to represent that. How will I show that? I will show it a point over here. So this is my point R. So what is this point R? Basically the point R is this much is theta 1 plus theta 2. Fine. Now suppose I see my OP distance is 2 units. Okay, OQ distance is 2.5 units. I need to multiply them. Okay, so everybody knows 2 into 2.5 will be 5. So OR will be 5 units. That's what the way we can multiply the two complex numbers. Okay, so in this case, suppose I say that the complex numbers will be written as mod z1 into z2. So mod z1 into z2 is nothing but what? r1 into r2 is equal to mod z1 into mod z2. This much one should know. And also argument mod z1 z2 is equal to theta 1 plus theta 2, which is theta 1 is over here, theta 2 is over here, and this is theta 1 plus theta 2 is equal to erg z1 plus erg z2. Fine. So this is the way we can in short multiply the two complex numbers z1 x1 plus I by 1 and z2 which is x2 plus I by 2. Okay, now we'll move forward with the division of the complex numbers. Okay, now to understand the division of complex number, again I drew a Argand diagram. Okay, and same thing I can say that my first complex number is z1 is x1 plus I by 1, z2 is x2 plus I by 2. I need to divide them. Okay, so I'll represent them first by z1 is x1 plus I by 1 is equal to r1 cos theta 1 plus I sin theta 1 is equal to r1 e to the power I theta 1. z2 is x2 plus I by 2 is equal to r2 cos theta 2 plus I sin theta 2 is equal to r2 e to the power I theta 2. This is same over here also. Okay, only thing change is what? The quotient. So I can say z1 by z2, the quotient of two complex numbers z1 and z2 is given by r1 e to the power I theta 1 divided by r2 e to the power I theta 2 is equal to obviously r1 by r2 e to the power I theta 1 minus theta 2. Okay, so what I can say over here in short, that the quotient of complex numbers or division of the complex numbers z1 and z2 is a complex number and its real part is r1 by r2 and imaginary part is obviously e to the power I theta 1 minus theta 2. Okay, so we can write z1 by z2 mod is equal to r1 by r2 is nothing but mod z1 by mod z2, and similarly argument z1 by z2 is equal to erg z1 minus erg z2. Okay, so over here we can say what? That the complex numbers z1 by z2, okay, is represented by the point r, fine, which has polar coordinates what? r1 by r2, okay, this part, and angle is how much? Theta 1 minus theta 2. In this case, OP is Z1, P point is Z1, Q point is Z2, and R point is Z1 upon Z2. Okay, so real part for that will be R1 by R2, and polar coordinate will be polar coordinate R1 by R2 and theta 1 minus theta 2. Okay, so we can say in short, OR is equal to, I can write that also, OR is equal to OP by OQ is equal to R1 by R2. Okay, so and this is going to make angle of how much? Theta 1 minus theta 2 with the real axis. Okay, this is what we have understood from the division of the complex numbers. So this is the way we have finished with the addition, subtraction, multiplication and division of the complex numbers. Now the next topic after all the mathematical operations is de Moivre's theorem. When the moment you say theorem means this should have some statement. So we'll write the statement first, and one should also know where it is used. So this theorem is basically useful for to find the power and roots of a complex number. What is the statement? Cos theta plus I sin theta raised to the power n is nothing but cos of n theta plus I sin n theta. Okay. Now what is n basically? N is a power. It can be 1, 2, 3, 4, anything. Okay. So how we can prove this? We can prove with our normal formula what we got earlier. So we can say in short that cos theta plus I sin theta is nothing but e to the power I theta. This is basic. The step number 1 is this. Then what we can do? We can raise this LHS, which is cos theta plus I sin theta raised to power n. Okay, put a bracket and raised to power n will give me how much? E to the power I theta, e to the power I theta, because raised to the power n. Okay, e to the power I theta. This will go on till n times. Okay, so this is multiplication. So using laws of indices, I can write e to the power I theta plus I theta plus I theta, so on till n terms. Okay, this is nothing but what? E to the power I n theta. Okay, so this we can write e to the power I inside the bracket n theta. Okay, so therefore cos of theta plus I sin theta raised to the power n will be cos of n theta plus I sin n theta. This is in short the smallest possible proof of this de Moivre's theorem. When the statement is cos theta plus I sin theta raised to n will be cos n theta plus I sin n theta. So when I get this term, okay, obviously the answer should be cos n theta plus I sin n theta. So hardly once I know this basic statement, this is not a difficult, because just here I did raising the power of this LHS to the power n. Okay, this is as simple as possible. Now next topic is what? Power, roots and logarithm of a complex number. Complex number is z only. Okay, so we'll first begin with power. So now we say that complex number z is basically x plus iy. Okay, and we say that this is nothing but r e to the power I theta. These two forms we have seen it. Okay, now suppose I say that the exponential form z is r e to the power I theta. I'll use this and say, suppose now z to the power n, because I need to study power. Z to the power n should be how much? R e to the power I theta raised to n, which means r to the power n and e to the power I n theta. Okay, now just now we have studied the de Moivre's theorem. What de Moivre's theorem said? Z to the power n is r to the power n inside the bracket cos n theta plus I sin n theta. I can put brackets over here and this is full bracket. Fine. Now once we know this, that z to the power n is r to the power n cos n theta plus I sin n theta. So this equation gives us what? That mod of z to the power n is nothing but r to the power n, that is z to the power n is z raised to the power n. Okay, and similarly erg z to the power n will be n erg z. Okay, so the power of a complex number z, okay, are basically multiplied values. Okay, because the reason is what? E to the power I theta is e to the power I theta plus 2n pi. Now what is the values of n here? Will be 0, plus minus 1, plus minus 2 and so on. Okay, so which means what? E to the power I theta plus 2n, suppose n is 0, e to the power I theta is same, then 2 pi, then if it is n is 1, 2 pi, if it is 2, 4 pi, if it is 3 to the 6 pi, 8 pi and so on. Okay, so this will help us what? This will help us to determine the powers of a complex numbers which are, okay, restricted to only the principal values. That is the basic reason as far as knowing the power of a complex number is concerned. Okay, then we'll go to the roots of a second one is roots of a complex number. Now roots means what? Basically I need to know the nth root of a complex number. Okay, so in determining these roots, okay, so I'll say my complex number z is equal to x plus iy. I need to find out the nth root of the complex number z, which will be how much? Z to the power 1 by n. Okay, now z to the power 1 by n will be r e to the power I theta, okay, raised to the power 1 by n. So this will be r raised to 1 by n e to the power I theta divided by n. Fine, r to the power 1 by n e to the power I theta divided by n. So we are through. Now this we will write in a little better way or little more clearer way. Okay, which means what? This theta angle, okay, is increased by 2 pi k. Now what is my k? The positive integer, like this I did it. Okay, so I'll write z to the power 1 by n is equal to r to the power 1 by n inside the bracket e to the power I, okay, theta plus 2 pi k, okay, raised to 1 by n. Okay, this is the way I will be doing the clarification of the a little more in details. Okay, so I'll write r to the power 1 by n inside the bracket cos of, now this is the angle. What is the angle? Theta plus 2 pi k divided by n, fine, plus I. E to the power I theta is how much? Cos theta plus I sin theta. So I sin theta plus 2 pi k divided by n. Done. So now this equation gives what? The n distinct value. Fine. So what is the k ranges from? K is ranging from 0, 1, 2, etc. Okay, till n minus 1. Understood? So the values will be what? The arguments of these n roots will be how much? Suppose I say my k is 0. So the arguments of the nth roots will be theta by n. Okay, theta by n, because this term will be 0. Okay, second term, suppose k is 1. So how much I will be? Write the value theta plus 2 pi, okay, n divided by n. Okay, sorry, 2 pi only, because k is 1. So 2 pi. The third value will be theta plus this up k is 2. First k was 1, so 2 pi. Then it will be 4 pi. Okay, and then 6 pi, and so on. The last term should be theta plus 2 pi into n minus 1 divided by n. Fine. Now this expression, what we did, r to the power 1 by n is what basically is the positive nth root of a positive real number. Okay, now suppose we say z is equal to 1. Okay, so z is equal to cos of 2 pi k plus I sin 2 pi k, where k was ranging from where? 0, 1, 2. Fine. So which means z is equal to 1, it is equal to e to the power I k into 2 pi. Fine. Next, so what we can write over here? Z to the power 1 by n. I need the nth root now. What is the value of z? 1. So 1 to the power 1 by n should be e to the power I, okay, k 2 pi raised to the power 1 by n. Okay, what does this mean? This means cos of k 2 pi by n plus, because e to the power I theta, what I taught you, cos theta plus I sin theta. Understood? So here this is my theta, so I wrote cos theta k 2 pi this power is over here, plus I sin k 2 pi by n. Fine. Now what is this value of k? I said 0, 1, 2 up to n minus 1. Okay, so the n values given by this equation are basically the roots of unity, because I took z to be 1. Done. So these values are symmetrically spaced and lie on the unit circle on a complex plane because mod of z is equal to 1. So this is a simple logic to find out when we are trying to get the roots. When z itself is 1, what I wrote over here, z is 1, z to the power 1 by n is 1 to the power n by n. So how much, what is the formula? Cos theta plus I sin theta. Understood? Okay, so it will be simple for us to write the values in this fashion. Okay, now we'll just do this small definition before we stop. So we have finished power first, okay, then we have finished the roots, and now we will define what they mean by logarithm of a complex number. So logarithm of the complex number. Now in defining this, what you need to say, that my complex number z is x plus iy. Okay, and we write in exponential form r e to the power I theta. Now if you take the log of this exponential form, okay, so with respect to, suppose we take, I'll write z r e to the power I theta, and I'll say take log, okay, with respect to base e on both the sides. So I can say ln z LHS is equal to ln r e to the power I theta. Done. How will I write this? I'll write ln r plus ln e to the power I theta. Done. Now suppose I say LHS ln z is p. Okay, so I can write p. So we can say let ln z is equal to p. So p is equal to ln r plus I theta, because I took ln and e, so only I theta will remain. So this is my simple way of finding the logarithm of a complex number z. So this equation gives me what? Theta will have, okay, infinite number of values. Okay, so the complex number p, okay, is equal to ln z. This we wrote, na? P is ln z, has infinitely many logarithms differing from each other by a multiple of 2 pi. Reason behind what? Because the values are differing by a multiple of basically 2 pi itself. Okay, so this is a simple definition of, we can say, of finding the logarithm of a complex number. With the complex number in an exponential form, take the log with respect to e, so we get this simple possible statement. Okay, so we have finished all the algebraic calculations, addition, subtraction, multiplication, division. Along with that, we have finished with the what is called as power, roots and logarithm of a complex number. Now next lecture I will upload mostly today itself, which is trigonometric, exponential and hyperbolic functions, and then I'll solve the problem on the whiteboard, okay, where you will be able to discuss also, and if you have any doubt you can very well come forward and ask also. So this is the theory part which I finished almost. So one more topic of trigonometric, exponential and hyperbolic function, that theory I will complete, and then we'll move towards the more problems over here. Okay, so this is, I suppose, where we'll stop. So go through it. Any difficulty, feel free to ask.